How many arrangements of the word permutation are there in which the vowels occur in the order A, E, I, O, U, from left to right, though not necessarily together? Okay, disclaimer, I think permutations and combinations are a really interesting topic, but I don't like it because I'm not very good at it. It's always really confusing. It's hard to know whether your answer is right or not. And the person who sent this to me got an answer. It disagreed with the answers in the exercise. So how do you know? What's the actual way to go about getting the answer? And there's lots of different ways to get the answer. Lots of different methods. Which one's the best? So I've done a lot of thinking about this. And here's the answer that I've come up with, okay? Now, by the way, I'm going to set this out the way that I would set out an answer if this was an exam that I was doing. And there's going to be, full-on sentences and that kind of thing. And that's what perms and coms is about. Like, you have to explain your logic and not just have numbers down with no explanation as to why. Because when someone's marking it, what they're looking for is an explanation of understanding, a demonstration of understanding, and not just can you, pluck out random numbers which will get you a right answer at the end. So here we go. The word permutation, let's just think about that for a second. Before you think about the vowels, okay? The word permutation has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters, okay? 11 letters, right? So the first thing I would set out is that forgetting about what the letters are, right, and any kinds of conditions on them, I'm going to add conditions as I go. I'm going to say there are 11 factorial ways of arranging 11 letters. So that's pretty sort of standard arrangements. Before you even get to permutations and combinations as a topic, you've got 11 slots, and how many choices do you have for the first slot? You've got 11 because you've got 11 that haven't been picked. Then how about the next one? Well, you've got 10 left, and then 9, and so on. So when you multiply them all together, you get 11 factorial. Okay, right. So this is kind of our baseline, right? This is my first thing, which I'm going to say, and I'm now going to try and drill down and become more specific and add conditions on. Okay, so let's think about the next thing. When you have a think about all of the arrangements that you're going to get, these 11 factorial arrangements, massive number, okay? In these arrangements, the vowels will not always be in order. So that's a bad thing for us, right? Because we only want the ones where the vowels are in order, okay? So how many of these 11 factorial arrangements, ways, how many of them have the vowels in order? Well, to answer that, I want to think about how many different ways are there to get the vowels, right? How many different ways are there to order the vowels? And the answer is, because there are 5 vowels, A, E, I, O, U, right? How many ways are there to reorder them? Well, the answer is there are 5 factorial ways to order the vowels, right? Now, here's the thing. Out of those 5 factorial, what's that? I think it's 120 off the top of my head. Out of those 5 factorial ways, how many of those ways am I interested in? And the answer is, I'm only interested in one way, the specific way where all of the vowels are in this order and this order only, okay? So since there are 5 factorial, 120 different ways, and I'm only interested in one of them, right? That means I've overcounted by a factor of 5 factorial, or a factor of 11 factorial, 120, right? So therefore, there are 11 factorial divided by 5 factorial ways where I've got 11 letters and the vowels are in order. Okay, so can you see how, because I've overcounted in my original calculation, to compensate, I divide, right? That'll divide me down and get 5 factorial less as a factor ways of arrangements, okay? So now I've got, so far, this is an 11 letter word, right, with 11 letters to choose from. Now I've narrowed down that I only want the ones where the A, E, I, O, and U are in order, okay? Now I have to think about, are there any other limitations? And the answer is yes, because in my word, 2 of the letters are identical, okay, the 2 T's. Now, that means that I can arrange those 2 T's in 2 factorial ways. If I had 3 T's, it'd be 3 factorial more ways, right? So again, I've overcounted because this permutation, this way of spelling it, if I swap these two t's around, would look exactly the same. But this way of counting would double them up, right? So therefore, since there are two identical letters, right? And again, like I said, I'm actually going to write this down as part of my answer. Because it demonstrates that I know where the numbers that I'm writing are coming from, right? We've only counted by a factor of 2 factorial. Okay, so just like with the 5 factorial before, I have to divide through by that, right? And this is all the conditions, right? So therefore, there are 11 factorial on 5 factorial, 2 factorial ways. And when you punch that into calculator, you get 166,320 ways in which you can arrange those letters given those conditions.